In this lab, we'll be looking at chemical tests for cations and anions. A cation is an ion that has a positive charge. An anion is an ion that has a negative charge. We'll be looking at the chloride ion test, the sulfate ion test, the bicarbonate and carbonate ion test, the phosphate ion test, the sodium ion test, the potassium ion test, calcium ion test, as well as the ammonium ion test. You will perform each experiment twice. The top box will always be positive, and that is your base for comparison for your bottom box using your unknown. At the end of the experiment, you will be able to tell what the cation is for the unknown and its charge. You'll be able to tell the anion contained in the unknown and what its charge is. You'll be able to determine the formula as well as the name for the unknown compound. Okay guys, so this is going to be the chloride ion test. So what we're going to do is we're going to take a known solution that contains chloride. So we're going to take sodium chloride and we're going to use a healthy squirt. Whenever it says 1 to 2 milliliters, we're just going to do a healthy squirt. We're going to put it in there. And it says we're going to need 1 to 2 milliliters of nitric acid. So we have nitric acid right here. I'm going to put a little squirt. And we're going to put 10 drops of silver nitrate. So we're going to pull a squirt of silver nitrate to see what it does. Okay. So it forms what we call a precipitate. Okay. So precipitate is an insoluble solid that forms whenever you mix two liquids together. Okay. So now our unknown will be positive for the chloride ion if it looks like this. Okay, so we're going to be using our unknown, number 24, to determine if it's positive for the chloride ion. So what we're going to do is we're going to take 1 to 2 milliliters of the unknown solution. Okay, so we're going to put a nice squirt. And then we're going to put 1 to 2 milliliters of nitric acid. Squirt. And then we're going to put some silver nitrate. Okay, so it doesn't appear that a precipitate was formed, so we're going to say that this one is negative for the chloride ion. Okay, so the next test we're going to be looking at is going to be the sulfate ion test. So what we're going to do is we're going to take a test tube and we're going to squirt some sodium sulfate in the test tube. It says 1 to 2 milliliters, so do a healthy squirt. Okay. We need 1 to 2 milliliters of 6 molar hydrochloric acid. So we use our hydrochloric acid. Like that. And it says we're going to do 10 drops of barium chloride. So barium chloride is right here. And so like we did before, we get a white precipitate. Okay, that forms, it turns white. Now, we're going to come back and do our unknown with the sulfate ion. Okay, so we're going to have our unknown. We're still dealing with unknown number 24. So we're going to test it for the sulfate ion test. So it says we're going to put 1 to 2 milliliters of our unknown. So we'll do a nice squirt. We're going to take 1 to 2 milliliters of hydrochloric acid. Squirt. And we're going to take 10 drops of barium chloride. So we'll do a squirt. Okay. As we can tell, nothing happened. Okay, so it didn't turn white. So this is going to be negative for the sulfate ion. So the next test we'll be looking at is the bicarbonate ion test. Okay. For this, you're going to need sodium bicarbonate. So this is what it should look like. So we'll do a squirt of sodium bicarbonate. And then we're going to do a squirt of hydrochloric acid. Okay, so what should happen is it should fizz. there were bubbles produced. Okay, so what we're going to do now is we're going to look at our unknown and see if it does the same thing. Still doing unknown number 24. We're going to do the bicarbonate ion test for this. Okay, so I'm going to take a squirt of my unknown, and I'm going to take a squirt of hydrochloric acid. Okay, so I'll try and make sure we get close to the camera so we can actually see the fizzing going on. Okay, so it fizzed. So I would say that it is positive for the bicarbonate ion. Okay, so the next test we're going to look at is the phosphate ion test. So I'm going to grab a new test tube. So it says we are going to take 1 to 2 milliliters of sodium phosphate, and we're going to do, this is going to be the phosphate ion test. So it says we're going to take 1 to 2 milliliters of sodium phosphate. So sodium phosphate is going to be right there. And we're going to take 20 drops of ammonium molybdenate. Okay, so we got that right here. And we're going to just put a healthy squirt in there. And it says we are going to take 1 to 2 milliliters of nitric acid. So I have that right here. And we're going to see what it does. Okay, now it says we're going to place in a test tube in a boiling water bath for 5 minutes. Okay, so we'll come back to see what that looks like in just a second. Now, we're going to do our phosphate ion test for our unknown. So we're still dealing with unknown number 24. So we're going to take 1 to 2 milliliters of unknown solution. Okay, we're going to put it in our test tube. We're going to take 20 drops of ammonium molybdenate. And we're going to put it in there. It says we're going to do 1 to 2 milliliters of nitric acid. And we are going to put it in the water bath. So we'll come back and we'll look at the results in just a second. Okay, so what I'm going to do is I'm going to show you the known. So this will be the top box for your phosphate test. Okay, this is what it should look like if it's positive. Okay, it should have turned yellow. Okay, so we're going to, give me just a second. And then our unknown did not turn yellow. So we're going to say that it's negative for the phosphate ion test. The next test we're going to look at is the calcium ion test. Okay, so what we're going to do is we're going to take calcium chloride. I squirt calcium chloride, and it says we're going to mix it with some ammonium oxalate. So an ammonium oxalate right there. Okay, as you can tell, a white precipitate was formed. So we'll come back and we will use our unknown to test it for the calcium ion. Still using unknown number 24. We're going to take 1 to 2 milliliters of that. So we'll take a squirt of that. And we're going to mix it with some ammonium oxalate. Okay, if it's positive, it should make a white cloudy solid. And as you can tell, it does not. So it's going to be negative for this ion. Okay, so the last test we're going to look at is the ammonium ion test. Okay, so the top box says that we're going to take 1 to 2 milliliters of ammonium oxalate. So I'm going to take a squirt of that, put it in my test tube. And it says we're going to mix 3 drops of sodium hydroxide. The drops must be straight down to the liquid without touching the sides. Okay? So we're going to be a little more careful with this one. And it says straight into the liquid. So 1, 2, 3. Okay. Now it says we're going to go and do a water bath and we're going to test the pH of it. Okay. So I'm going to get me some pH paper. Okay. So I'm coming back and I'm trying to do this. Stick it down in there to test the pH. You can see the end of it is turning blue. It's producing some vapors. So that means that it's going to be a base if we go and look at our pH paper. So our pH paper says that it would have a pH of around 10. Okay. Now we're going to repeat the same thing. So we're still using unknown number 24. We're going to take a squirt of that. We're going to put it in our test tube. And then we're going to take 3 drops of sodium hydroxide and we're going to put it down and we're going to make sure that it doesn't touch the sides the best that we can. So it says do 3 drops. So we're going to stick it down there. 1, 3. Okay. And we're going to put it in our boiling water bath. Okay, so I'm going to adjust my camera just a little bit so you can see a little bit better. And I'm going to look at what the pH is of it. Okay, so I'm going to use a pH strip, and it should turn blue if it's positive for that test. Okay, and it's not turning blue, so we know that it's negative for the ammonium ion. Is going to be dealing with flame test, and this is actually one of the cooler parts of lab. So what we're going to do is we're going to take a nichrome wire, okay, so our nichrome wire, and we're going to heat it up, and then we're going to dip it in some hydrochloric acid to clean it, clean the tip of it like that. So we've got some stuff on it. So we've got to clean it really well. It looks like it's got a whole bunch of stuff on it. So it's got some copper. Okay. So, let's see if I got another one. So what we're going to be doing is we're going to look at different colors of flames. Okay. Yeah, there we go. That's a good one. So we clean it like that. So the first one we're going to look at is we're going to look at sodium. Okay, so sodium should burn like this. So if you're looking at fireworks, fireworks have different colors because they have different metals in them. So this is how they get them to burn at different colors. So the sodium flame test should look like this. It should be a bright orange. Okay, so if our unknown is positive, it's going to look like this for sodium. Okay, so what we're going to do is we're going to take that and we're going to put it in some hydrochloric acid and we're going to clean it up again. Okay, so this is just burning off. Make sure we burn it off really good. Okay, so the next one we're going to look at is going to be, let's look at calcium. Okay, so calcium. Okay, so our calcium ion. Will look like that. It's a reddish orange flame. Let's see if I can get it to go again. There we go. So that's what our calcium flame looks like. And we already know that our unknown does not have calcium in it from our calcium ion test, so we know it's not that one. Okay, so let's look at sodium. I mean, this is potassium, sorry, potassium. So potassium has a lavender flame. Tell right there, it's gonna be lavender. Okay, and the last one I want to show you, which is always a really cool one, is going to be copper and how it looks when it burns. So characteristics of copper. Copper 1 is usually like a green compound. Copper 2 characteristic is usually it's blue in nature. So look at what a copper flame will look like. So this is going to be copper 2. If it'll go, there we go. So it's going to be green. That's pretty cool. Okay, so now that we've done all of our flame tests and we looked at what each one looks like, we're going to see what our unknown is going to look like. Okay, so we're going to clean it again. You got a little bit of everything on it. That's why, especially this copper, it likes to stick. Okay, so let's do our unknown. So our unknown, so this is unknown number 24. So we know what the flame should look like if it's positive for a particular ion. Okay, so this looks like it's going to be the flame, bright orange. Let's see if I can get it. Bright orange for sodium. Okay, so it's going to be positive for sodium. Okay guys, so that has been your ion test lab, cation and anion lab, and I'll come back and show you how to do the last portion. Thanks. So from our experiments, we could conclude that our unknown was positive for the sodium ion, and we know that the sodium ion carries a +1 charge. We know that the anion contained in the unknown was the bicarbonate ion because it fizzed in the bicarbonate test. So the bicarbonate ion carries a -1 charge. We should be able to write the formula for the unknown compound, and we should also name the compound sodium bicarbonate. Don't forget to crisscross if you have to crisscross for your formula. Post-lab questions. Why is it important to avoid tap water in this experiment? Well, tap water contains minerals and ions in it, such as fluoride, chloride, phosphates, and calcium. Second question. A colorblind student has difficulty distinguishing between the sodium and calcium flame colors in the flame test. The unknown solution produced white solids when ammonium oxalate was added in the calcium ion test. Which is present, calcium or sodium? Well, it's positive for calcium because it tests positive in the calcium ion test. While running a bicarbonate test, Ashley's solution turns pink. Is this a positive result for the bicarbonate ion? Well, we know from our unknown that if it was positive for the bicarbonate ion, it would fizz.